Hey everyone, welcome back to the College Algebra playlist. In this video, I want to continue our discussion of functions. Alright, we're going to take a look at a special type of function called one-to-one functions. Alright, and we'll also take a look at something called the vertical and horizontal line tests. Alright, so let's dive into it. Okay, here we go. Before we dive into the new content, I want to give a brief recap of some of the things we covered in previous videos on functions. Alright, first let's write down a definition for relations. Alright, a relation is a set of ordered pairs. The set containing the first components of each ordered pair, the x-coordinates, is called the domain. And the set containing the second components of each ordered pair, the y-coordinates, is called the range. Alright, let's also write down a definition for functions. Alright, a function is a special type of relation in which every possible input value corresponds to exactly one output value. Alright, the input values make up the domain and the output values make up the range. Okay, so given some relation, if an input value corresponds to more than one output value, then the relation is not a function. Alright, let's take a look at some examples. Alright, these relations are functions. Alright, the blue function here, y equals 2x squared minus 3x plus 4, that's a function, right? That's a parabola. Alright, we know what that looks like. Alright, and the red and the green functions are here as well. Alright, these are all examples of functions. These relations, though, these are not functions. Alright, we looked at this equation in the previous video, right? This is the equation of a circle, right? X squared plus y squared equals 1, right? And it's not a function, because when we try to isolate y, we end up with y equals plus or minus some business in square root. Alright, we have two outputs corresponding to the same input, alright, and that's not allowed in the function realm. Alright, we have the same problem here with this red function. Alright, if we isolate y, if we take the square root of both sides, we'll get y equals plus or minus square root of x. Alright, so two outputs for the same input, that's not a function. Alright, and we have the same problem here with this absolute value function in green. Alright, so notice that it's a bit awkward and clunky to argue why these relations are not functions in words, right? If you just stick with a verbal argument, it's awkward and clunky, all right? We say, hey, I wish there was a way to argue graphically that something is or isn't a function, all right? I want something more elegant than the verbal argument, all right? And we do have something like that, right? It's called the vertical line test, all right? The vertical line test is used to determine whether a graph represents a function, all right? If we can draw a vertical line that intersects a graph more than once, then the graph does not represent a function. All right? I want you to pay attention to this part right here. If we can draw a vertical line, all right, we only need to find one. All right? Out of all the vertical lines we can draw, right, we just need to find one that intersects a graph more than once, and we can argue that that function, that graph is not a function. All right? Let's look at an example. Here we have the function y equals 2x squared minus 3x plus 4. All right? Any line that we draw, right? Any vertical line that we put down, it's just going to intersect the graph once. All right? It only intersects the graph once. So it passes the vertical line test. So we say that this relation is a function. All right? But if we take a look at the circle again, right? We took a look at this circle briefly in the previous video. All right. So if we take a look at this, we see that we can draw a vertical line that intersects the graph more than once. All right. It hits the graph twice here. All right. So this fails the vertical line test. Therefore, the relation x squared plus y squared equals 1 is not a function. All right. We have an input value corresponding to two output values, and that's not allowed in the function realm. All right? Let's look at some more examples, sort of rapid fire here. All right? Pause the video and see if you can come up with a reason why this function is or isn't a function. all right? Here we can see that whatever vertical line we draw, right, any line that we draw, it's just going to intersect the graph once, all right? So this passes the vertical line test, so it is a function, all right? How about this graph on the right? All right, does this represent a function? That's the question, all right? And we say no, it's not a function because of this vertical line here, right? It's hitting the graph in more than one spot, all right? So it fails the vertical line test. Therefore, y squared equals x is not a function. All right, here's a couple more. Here we have y equals the absolute value of x plus 2, all right? We can see that wherever we draw our vertical line, right, it's just going to hit the graph once, all right? So it passes the vertical line test, so it is a function, all right? But over here, right, absolute value of y equals x, here we can draw a vertical line, right, and it hits the graph twice, okay? So it fails the vertical line test, so it's not a function, all right? Next, let's talk about one-to-one functions, all right? This is a special type of function in which every output value corresponds to exactly one input value. There are no repeated x or y values, all right? So let's take a look at this part right here, okay? It says it's a function, all right? So by the definition that we had on a previous slide, right, every input value corresponds to one output value, all right? So a one-to-one function not only has that going on, but it also has this. Every output corresponds to exactly one input, all right? So let's take a look at the mathy, fancy version of the definition, all right? One-to-one functions are also called injective functions, okay? If f of a equals f of b, right, if the outputs are the same, then that means that the inputs must be the same, all right? A equals b, all right? Here we have the function y equals x, all right? And we can see that every output value corresponds to just one input value, all right? So the function y equals x is one-to-one. However, with this parabola over here, with y equals x squared, take a look at these two blue points, all right? We have the same output value, 4, corresponding to two different inputs, -2 and 2, all right? So because of that, we say that the function y equals x squared is not one-to-one, okay? So once again, notice that's a little bit awkward and clunky to argue that verbally, all right? We need something more elegant, right? Something quick we can use to make a graphical argument, all right? So we're going to use something called the horizontal line test, all right? The horizontal line test is used to determine whether a function is one-to-one, all right? If we can draw a horizontal line that intersects a graph more than once, then the function is not one-to-one, all right? Here on the left, I have the function y equals x cubed minus 4x, all right? We can find a horizontal line right here that hits the graph more than once, all right? It intersects this graph 3 times, all right? So it fails the horizontal line test, all right? Therefore, the function is not one-to-one, all right? We have the same output value corresponding to 3 different inputs, all right? So it's not one-to-one, all right? Over here, this graph on the right, we can see that wherever we draw our horizontal line, right, anywhere in this graph, right, it's just going to hit the curve once, okay? So it passes the horizontal line test. So we say that this function is one-to-one, all right? Here, I have the function y equals 1 over x squared, all right? And if I draw a horizontal line right here, it's hitting the graph twice, all right? So it fails the horizontal line test. So we say that it is not one-to-one, all right? And finally, I have the function y equals 1 over x, all right? And we can see that wherever we draw this horizontal line, it's just going to intersect the curve once, all right? So it passes the horizontal line test. So we say that it is one-to-one, all right? That does it for this video. Thank you for watching, and like and subscribe.